presentations tonight. The first, the main presentation, is around MeshCore. And you've actually been able to get one of the developers of the, the developer of the application. Liam Cottle's L2DEV might give you a clue as to what profession he's in. So I'll let Liam, I'll stop sharing, and Liam, the floor is yours.
Cool. All right. I'm Liam Cottle, software engineer here in Gisborne, also a licensed amateur operator based on the call sign hiding in the corner there. So I'm going to run you through a bit about MeshCore and also comparing that to the likes of other networks like Meshtastic. You may have heard of that. I will get these slides up real quick and we'll jump into it. All right. First off, there's a little bit of a picture of a little solar antenna mesh node here that I built over a year and a half or so ago when I started playing with Meshtastic, and that's still up there, up on that hill, sending messages away. A few screenshots of the MeshCore app as well, if you haven't seen it. Alright, so what is MeshCore? It's a simple, secure, off-grid mesh communications system that uses LoRa, which is a long-range radio protocol. The world record directly between two mesh radios with this LoRa system is over 300 kilometers. There was another world record that was over 1,000 or so, but as far as I know, that wasn't using these little mesh radios. That was using some more crazy antennas, and it might have been LoRaWAN or something along those lines. It runs on low-power microcontrollers, such as the ones that you can see on the side here, a little antenna sticking up, a little microcontroller, and there's a couple boards down there in the bottom right. So for this mesh stuff, I recommend boards that are NRF52 based because they're very, very power efficient. You get about a week on 2,000 milliamp hours of battery versus some of the ESP32 boards that you might have heard of, such as a Heltec V3. This mesh stuff in LoRa operates in the ISM bands, such as 433 megahertz, 868, and 915, which are free to use without needing a license. It's all very, very low power stuff, so you won't be sending a kilowatt over the mesh. New Zealand primarily uses the 915 megahertz band. There is actually a default channel note down the bottom, but that is not correct. This is a copy paste of my Meshtastic presentation with a few changes, so disregard that one there. Up in the top right, there's a photo of some of the spectrum on an SDR of someone that's captured some LoRa packets. You can see here at the top right some of the wider bandwidth stuff, and then some narrow bandwidth down there in the middle. That's over in the UK, just a screenshot there. So what can you actually do with MeshCore? So the main feature of MeshCore is sending text messages directly between a couple of people or group chat across the whole city, or as sort of as far as your repeaters reach. There's a bit of a screenshot on the right there of just a conversation in one of our private radio club groups there. Nothing too crazy in the text, but that's sort of what you're looking like in the mobile app. So Wi-Fi, cellular, and internet connections are not needed. Each person would need a MeshCore Companion node, so one of those little radios that you saw in the previous screenshot. You can pair that with your phone or a laptop. There's also some standalone devices that I'll show you some photos of later on in the slides. And each person can communicate directly with another person if they're in radio range of each other. Otherwise, you can set up repeater nodes, ideally solar powered, and plonk them up on a hill, and that will increase your range for messaging people. It is secure encrypted messaging. Direct messages are AES encrypted. Private channel messages, so you can send group chat messages across the mesh there to more than one person, and everybody in that sort of channel will receive the text messages, and those are also secured with a secret key. So you sort of need that secret key to be able to send and receive messages there. We also have public channel messaging, and those are all public, so anything you post in there, anybody will be able to sort of read those messages. So very good for if you wanted to sort of send out alerts or announcements or something in your area there. Repeater nodes can still rebroadcast all the packets and all the messages across the mesh to contribute to further range without actually needing any of those encryption keys on it. Some example use cases of using MeshCore. So you can communicate with your friends and your family when the internet's gone down, or you could use it as your daily driver instead of WhatsApp or Signal or Facebook Messenger if you really like your off-grid messaging networks that you don't have to pay for. You could use it for tracking and messaging search and rescue volunteers in the field. You could use it for monitoring remote hardware, such as collecting battery bank voltages of solar-powered sites, or you could send commands to physical hardware, such as turning on water pumps. Also, you could collect telemetry from other sensors, such as water tanks. And I've actually built a water tank sensor node with MeshCore, which I request the telemetry over the mesh and plonk it into Grafana, and I'll show you some screenshots of that one a little bit soon. MeshCore versus Meshtastic. So some of you probably have heard of Meshtastic. This is another LoRa mesh node system that's been out for, I think it's about 5 years or so now, but only became popular in the last couple of years or so. MeshCore's come out since about January this year, 2025, although the primary developer, Ripple Radio, Scott there over in Australia, actually started working on some of the core stuff a couple of years ago, and then we jumped into calling it MeshCore to fix a few of the issues we had with Meshtastic. So in MeshCore, we have two main roles with different firmwares, sort of what you can do with the radio hardware. So we have a companion firmware and we have a repeater firmware. So a companion firmware is sort of like your client device. So it's what you pair with your phone, or it's a standalone device that you can send the text messages from. And then you've got a repeater firmware, and that's sort of what runs, pushing packets further across the mesh. They only repeat packets. They don't send text messages. You can't text as the repeater. It's just very, very basic. It just forwards packets on. So with MeshCore versus Meshtastic, it has a hop limit of 64, whereas with Meshtastic, the hop limit is 3, with a maximum allowed of 7. So that's how many repeaters your message or your data packet is allowed to pass through before it expires and it's no longer passed on. So essentially with MeshCore, 64 is pretty high. With the internet, it's also sort of 64. If you're building a network with more than 64, you're having a real good time. With MeshCore, it's pure flood routing and direct pathing. So pure flood routing is when you send out a broadcast message, every single repeater on the network will rebroadcast it if it hears it. Whereas with Meshtastic, there is a lot of different scenarios where repeaters and routers will or will not forward on messages, and there's a few different things with signal levels there where it tries to be smart about it, but we've kind of found that with all of that, you end up having people with companion devices or clients in their pocket that try to repeat on Meshtastic, and it leads to higher packet collisions, and the reliability of messaging is pretty degraded there. It gets a bit worse when you're limited by default to 3 hops. So with MeshCore, 64 hops, it'll just flood everything when it needs to, and it'll get out there. With direct pathing, in MeshCore, so this is something Meshtastic doesn't have, or they're playing with kind of recently, based on what we've learned with MeshCore, is direct pathing, and that's instead of flooding the entire network with your data packet, we can be smart and actually tag your message as it's sent across the mesh with the repeaters that it passed through, and then the recipient of that message knows the path that that packet took and can tell the sender, and the sender from that point forward can specifically use those repeaters to get their data to that recipient without having to light up the whole network every time. So it's sort of a flood, find a path, use that path from then on. If somebody moves across the network and the path is broken, it would flood to find a new path, and then you're back to only using the repeaters that you need. So this increases the reliability of text messaging quite a lot, especially in large networks, because you're only activating the repeaters that you need. You're not always flooding. So you're using less RF airtime as well, which means you've got more airtime available for other people to get onto the network and send messages. MeshCore is MIT licensed versus GPLv3. Not too sure if anyone's interested in talking about licensing or not, but basically MIT is sort of a license that allows you to do whatever you want. You can take our software, you can make it closed source, you can sell it, you can do sort of anything you want, whereas with Meshtastic being GPLv3, you are forced to open source anything that you build that uses any of their code. So if you were to fork the Meshtastic project, like the iOS app or the Android app or the firmware, and add something to it and try and sell it, you are required based on their license to also open source your project as well. So we're a little bit more freedom giving with the MIT license on MeshCore. You can sort of do whatever you want with it. We don't have any official support in MeshCore for internet linking. It is possible to do it, but it's not something we're really looking to provide as a thing. We want to sort of promote RF only, so solar-powered repeater nodes that are up on the hill and not connecting it to the internet, because otherwise, when the internet goes down, you're back to everything not working as it was before. Next slide, we spend a lot of time on that one. So the goals of MeshCore, we're looking for reliable messaging and packet delivery. We want to ensure the airwaves are as clean as possible, so not spitting out lots of telemetry all of the time. Telemetry in MeshCore is pull only, nothing's broadcasted. You have to ask for it. It won't just spit it out and block the airwaves for no reason. We want to ideally avoid connecting to the internet, as I mentioned before, but if you want to, you can do that. MIT licensed, anyone can do what they want with our firmware. We also want to provide useful tooling to make mesh network deployments easy. I'll show you some screenshots a few slides from now with some of the RF tooling for making it easy to deploy mesh networks and sort of gain some insight into how they're working. And another goal is to have a consistent experience across all of the platforms such as Android, iOS, Windows, and Mac. That was one thing that I found with when I was originally playing with Meshtastic and deploying that and getting new users to try it out, was when you were explaining the Android one to someone and then you needed to show the iOS, everything was completely different. The interface looked different, things were in different places, some features didn't exist, whereas with MeshCore, I've been building it with a cross-platform project called Flutter, and that allows me to have the exact same interface across Android, iOS, Windows, Mac, and web, and all of that. So it makes it very easy for other users of the app to actually explain to other users on different platforms how it works too. The adoption rate of MeshCore has been pretty crazy. We're up to about 5,100 nodes that have been uploaded to our internet map, which is just like a public map of, hello, look at my mesh nodes. You can publish them there if you want to. So this doesn't show the full coverage of mesh nodes in the world. This is just ones that people have decided that they want to publicly publish there. And over in the UK, where it's quite orange here, they've got quite massive networks over there. And I've got some screenshots of some actual mesh networks to show you very soon. Another interesting topic that came up was I had an email from an Italian speleological alpine rescue group, and they were trialing MeshCore for underground cave communication. So they had some of these little mesh nodes here. They flashed the MeshCore firmware on it, and they clipped them on to little hooks that they'd screwed into the walls here, and they were able to, over 7 or 8 hops in like a kilometer or two through these caves, send reliable messages back and forward from deep in the cave back up to the surface. So I thought that was quite interesting, so I wanted to share a couple of photos of that one. This is another use case for the MeshCore system. This is what I was talking about earlier with sensors and telemetry. I got a bit of a water tank up in Tolaga Bay, which you either have to drive up there and slap the tank with your hand to understand how much water's in it, or you've got to buy one of those little floaties that push up into the sky there and maybe point a camera at it to know how full it is. But what I've got here is a MeshCore sensor node. and a solar panel and a couple of batteries and a charge controller to keep it running, powered by the sun. And I've got a ultrasonic sensor which can tell me the depth of the water tank there. And so I feed that into Grafana, and it will fetch those metrics every hour or two across the mesh network there and plonk it on a graph. So I can see on the right here it's steadily decreasing, and I should probably turn the pump on soon. I actually had a water leak the other day, so it's going down pretty crazy. So how do you get started with actually playing around with MeshCore? So you could either build your own nodes, which a lot of people like to do, tinkering with radio and microcontrollers and all that sort of stuff, or you can buy a pre-made node from any of the sites that sell them. There's quite a few sites there that sell these little mesh boards that you can buy, and some of them are actually now factory flashing the MeshCore firmware on it, so you can buy it ready to go. I have some links at the end of the slides here that you'll be able to see, and I'll put a link to these slides in the chat when we're finished if you'd like to have a look. But it's pretty straightforward. You can get one of these radio boards, make a case for it, put a battery on it, and pair it with your phone with the MeshCore app and start sending messages, provided there's someone else to send messages to, so they'll need a node as well. Here's a photo of some of the different types of mesh nodes that are available. This is definitely not all of them, but this is a few of the ones that I quite like. So this one here on the top left is my main node at the moment, which is a Seed Studio, which that's the Weo Tracker L1. This one here was one of the original rack nodes that first came out with a 3D printed case. And this little pager and this TDEC here are some of the standalone devices that you can use on these mesh networks. So these two here don't require you to have a cell phone or a laptop or anything. They're actually, they have an interface and a keyboard where you can text and send text messages across the network. So you just charge it up, make sure it's on the right radio settings, and you can message across the mesh without a cell phone. One down the bottom left here is a little tracker tag. So this has a GPS in it and a battery and the LoRa radio. You can put the MeshCore firmware on there, and you could put this inside your car, or you could strap it to your doggo, or on something else and track that across the mesh. You can fetch the GPS positions from it. And here's some of the other devices that I've been flashing and packaging up and selling to a few people that have been interested in purchasing some. These are the solar-powered repeater nodes that I build. So with these little mesh radios, they can talk to each other directly if they're in range of each other. But let's say one person in the middle of the city wants to talk to someone up the coast, and up the coast is, let's say, 60 kilometers away. Well, those antennas definitely aren't going to be able to reach each other. So what you can do is you can deploy solar-powered repeater nodes up on high spots, and they will automatically mesh with other repeaters that they can communicate with within range, and your message will be able to bounce through those to get to the destination you want to send your message to. And here's a couple other ones, one up in Tolaga Bay and one inside some trees. It doesn't have the best signal, but it gets through. Another one, another solar node up on a massive pole here up in Motu, and one that was recently installed here up on Kaiti Hill. This is one of the commercial units that you can just buy pre-made from overseas. You don't have to build your own solar node. You could just buy it, and away you go. These are some of the custom units that I build with a 10-watt solar panel. We've got a little charge controller in there, 18 650 cells that you can't quite see, and then I put the mesh radios and software on there and plonk them on the hill. So here's some of the examples of the MeshCore networks that exist in the real world at the moment. So this is Gisborne, so this is where I'm based. We've got that little solar node. If I go back a couple of pages, this little node here up on this post, and this one here. So this is Takuri, and this one is Gadams Hill. If I go back to our little thing here, we can see Takuri's this node here, and Gadams Hill's over here. We've got signal stats and metrics, so you can actually see how your network is performing. So Takuri is able to hear all of these repeaters, and we can see that they have a pretty strong signal, apart from this one, which is this node here is by a cell phone tower, and cell phone towers really cause problems. There's all the fun RF side, but I won't go into that. This is a screenshot I found a while ago. I'm assuming it might have developed a bit further, but over in Tauranga, there's a little mesh growing over there as well. Here's a mesh core network over in Australia. Quite a few long distance connections there with really high signal strengths. And this one here over in Slovakia is massive. There's about 39 repeaters on MeshCore here, and you can see all the different signal stats. It's quite crazy. They've got a few hundred people on the network sending text messages every day, and they're saying it's pretty reliable, which is great to hear. Some of the tools that we have with MeshCore, some of you may have heard of HamNetDB. It's online ham radio mapping sort of application with RF tools. Some of their tooling was open source, and I was able to run that on my server and embed it into the MeshCore app. So you can click a couple of points on a map, and it'll generate terrain heights and elevations, and draw you a bit of a line of sight map, and sort of show you the obstructions that may be in the way of your antennas. So very useful. Can I put a repeater here and here, and will they be able to get through? Probably not with the hills, but the tools are very just for simulation. So you kind of got to go and deploy it to actually see. This is another tool for simulating potential coverage. You can click on a few spots on a map, and it will generate all of the line of sight points from that point. And so all of the red here, if we were to set up all of these repeaters at the lettered sites here, this is roughly sort of what the coverage would be on the mesh network. And these tools are all built into the MeshCore app and the MeshCore web app. We've also got some path tracing tools. Because when you go and deploy these solar repeaters, you sort of want to monitor them, right? You're sort of going away from the traditional cell tower network where you pay a monthly fee for your cell phone connection, and it's up to somebody else to monitor the mesh radios, and you go and set them up, and now it's up to you to monitor them. So taking over that role. So we've got these tools here for running traces, and you can click on repeaters and see how well they're propagating their signals there. This is a screenshot which was actually on the first slide, showing some of those LoRa chirp packets that are getting pushed around. There's some testing overseas at the moment with different settings, and it sounds like we'll be moving to these narrowband settings that work very well and can get out of the way of interference a bit better. So yeah, just sort of throw that in there as well. In the emergency sort of space here, I've been working with Gisborne Tarafi Emergency Management with Ben Green and his team here to deploy these solar repeaters that I've been building up the coast from Gisborne to Tolaga, Nota Bay, and further up there to interlink all the communities. So when all your cell phones go down and all that fun stuff, these are all solar powered, very low power, and ideally the emergency sites there will all be able to communicate through these, and the communities themselves will be able to communicate with themselves through these little solar units. One thing to keep in mind though is you're not going to get tens of thousands or 50,000 people on these units. They're very low bandwidth systems, but when everything has a bit of a bad time, all the cell phone networks are gone, fiber's gone, Wi-Fi and Starlink's gone, having some sort of backup system like this that's powered by the sun is quite useful there. And just a bunch of links to the official websites, our Discord, the Flasher, the map, and all that fun stuff. And a couple of the devices that I recommend, such as the Weo Tracker as a companion for sending the text messages and pairing with your phone. And if you just want to buy a repeater node to plonk on a hill that's ready to go, these solar node P1s do the job there. That was the end of these slides. I actually kind of slapped these together in the last 2 days. They were originally Meshtastic slides, and I just converted them over. I've been spending a lot of time working on the MeshCore mobile app and firmware and website and stuff, so And I only just got around to making these slides up as Steve asked me to present today. So if anybody's got any questions, feel free to throw those at me now.
So, yeah, it's Robin here from Waiheke.
Howdy.
Thanks, Liam. Really interesting. We're sort of trying to put a MeshCore system up. We did start with a Meshtastic and found some problems with it and sort of liked what MeshCore did. But one of the biggest advantages that we could see is the message rooms that you have in MeshCore.
Yes, that was one that I forgot to mention.
It seems that to me it seems like kind of the biggest thing, because with Meshtastic you have to be online all the time, and if you're not online you miss all the messages.
Yes.
If you have a room in MeshCore, you can just log in and have a look at what's happening anytime you want, and that seems like a major bonus to me.
Yeah, I'll just throw a quick info about that one, I suppose, to the rest of the group here. So in MeshCore, we've got the companion client, which is what you send your messages from. And you've got the repeater, which you put on a hill to extend your range of the mesh network, and what was just mentioned there is called a room server. So think of like a BBS or a chat room where you can log in and you can send a message and it will save it there, and you can go offline. The person you wanted to talk to is also offline. They can come on later, log into the room, and that message you posted is available to read. It's stored on the room device, which could be up on the hill powered by the sun, or could be at home, as long as it's in the network there.
Yeah, Liam, Charles Waiheke, can you hear me all right?
Yes.
Yeah, it's good to talk to you on a medium other than the International Space Station, if you remember our conversation
I do
back
recall
then.
that. Yes, very cool.
Yeah. Hey, so a couple of things. One of the things we've been struggling is finding aerials that actually resonate correctly. Everything seems to be sold on the 915, and it's off frequency. And I don't know what your thoughts are on that, and what you've been successfully getting with your hardware, eh?
Yeah, so most of those 915 antennas that are on like AliExpress and stuff that are labeled 915 are actually 868 antennas, because they can get away with it. It takes a couple of weeks for you to get it, and it's a couple of bucks, so people don't bother complaining about it. But you can trim those down. So there is an antenna company on AliExpress that I buy from, and they're called Gizont. Gizont. I was originally using the rack wireless blade antennas, which I think were about 3 dBi gain, but they're actually indoor rated. So I found on some of the sites there the condensation and a bit of rain and water was getting in them, and then they were no longer working. So you go up the site and go, oh, lovely, why isn't this working? And then you find the antenna's full of water. But what I've switched to is those Gizont antennas. They're N-type. I think they're listed as either 5 or 10 dBi, which is probably a lie. But they seem to be working pretty well. I've tested them on the Nano VNA, and they're about a 1.2, 1.1, 1.1 or so SWR at about the frequency that I'm using here on 915 or 917. Yeah, so that's helpful.
Liam, can I just highlight the point-to-point antenna tool in your app, the frequency point-to-point testing tool? An unbelievable tool. I mean, there's so many good things about the stuff you do, but that point-to-point tool is absolutely fantastic. Great for repeater setups, etc., for our AREC operations and things. Really, really handy. Yeah, so well done for doing that. I think that's absolute gold in the app, apart from anything else.
Cheers. Yeah, just finding all the tools and smashing them all together, and away you go. But yeah, all the antenna tools and the coverage tools and everything in the MeshCore app at app.meshcore.nz. Those can be all used. You don't actually have to have any of the MeshCore hardware or devices at all. You can just use those RF tools if you feel like it.
Cool. Well, thanks so much, Liam. That was a really good presentation, and it can certainly see the differences between MeshCore and Meshtastic, and why for us it makes sense to move towards MeshCore and that. Yeah, so well done. Thank you so much for the time you've put into that. It's really appreciated.